Hello everybody. Today it's gonna be part one of a little series I'm gonna try. And just trying to explore and if I can actually make a map for Scrap Mechanic. So obviously we got beacons, you can see here. Other than that, got obviously these two preset ones. You get around and there's beacons. Though they don't really show much. Also you can change the symbol, colour, and essentially you can show a lot. But if you want to show more exactly where stuff is located around it, you'll essentially need a map for that. If I know where stuff is, so let's say I wanted to know where all my warehouses are. I could go look at this, but this doesn't really tell me exactly where they are. I think, so back. And if you have a lot of beacons, you're putting a lot of these turned off as well. We'll have to go around turning off to see where they actually are located. As it will start to spam the map eventually. So, and I was curious if, as there's no coordinate system, Scrap Mechanic, if I could actually make my own, I think. It's an interesting concept. I've mostly worked out at this point. About 3 days of research and 2 of trial and error. And here you can also see my test rig. And yeah, so as you can see, it uses a total of 6 beacons. Those 2 are not part of it. See, one's my vehicle, and one's try to work out how much a meter is. And for anyone else, to be honest, I don't really know. It's somewhere in the middle of some level blocks. I don't actually know. So, for the purpose of finding out what the correct X and Z, I'm looking at placing a beacon here and a beacon there to get a rough idea. So yeah, so these don't actually really work, I think. But if I was to show you, so here, about 1 meter away, if I was to remove those, actually go a bit closer, I'm 0, son. So it's like somewhere around there is how I get some 0, but I don't actually know what point this goes off of. So I step back a bit. I'll see 1 there. Now 2 here. So 2 here. Now I'm 1 there. So it's like it's 4.5 is a waft place, I think. And obviously I can't do halves in this, so this is on 5s currently. So yeah, we're just going to use beacons. And those who are curious, I don't know how to code in Scrap Mechanic, but I do know how to code in Python. So yeah, I did this all in Python. So obviously if I just pick random destination, also you can see I've tried some places. So there's 3 that worked here, and this one didn't work. I'll get into why. It's mostly just due to it being close to this. So, from some of my testing, whenever I did something close to this line. And that's probably mostly caused from the fact if you look at beacons, distance, it only does it there. I don't have any decimals, like it's 0.5, and obviously it's 4.5 blocks-ish for a meter. So yeah, I sort of lose a lot of data in that. I could be within like 4.5 blocks of those numbers to go up another number. So that does mess with the results a little bit. So some of these might be slightly off, but it's a general place. The hardest part was to first of all learn how to triangulate essentially. And no, I'll just give you an example. Let's pick a random place. Let's pick here. He's not painting. It's painting. So if I pull up my calculator, okay, now see as you see on the screen, this is from just a bit earlier. But I'm just gonna go down here. Okay, also open the logbook so you can see all the beacons. Then we get the calculator. And obviously I've done this, coded it. So top ones is an upwards arrow, bottom ones is a downwards arrow, and then obviously color coded each of the towers. So top green is 21, bottom is 20, top red is 18, bottom is 18, top blue is 14, and 13 for bottom. As you can see here, X is 14 point and Z is 11 point. Now, to actually work out if that's correct or not, just grab beacon, put it on the line. So that will be measuring the Z coordinate, as it'll be doing that axis, and that'll be doing X axis. So if I pull the logbook out again, so if we look at X, which one's doing which? Am I in the right spot? Slightly off. I didn't actually know where I was standing on this pad. I think I was in roughly the middle. Yeah, obviously it's a 1 or 2 off, I think. It does vary a little bit. Also, I don't know if I'm standing in the exact spot, I think. Purple will be X. So X is meant to be essentially 15. But also you can see it's about 1 and a little bit off, I think. Lacking decimals for beacons. So we don't get the exact distance. We get a rounded up version essentially. And Z is 11. Well, 11.1-ish. You round it. And 12 up here. So 0.9-ish off. So it's pretty accurate, I think. And I guess I should probably move on to essentially the fact that this doesn't have to be right in this zone. I can essentially go over here if I wanted to. No, I just... And it also... You know, let's just start with a different test. So see, this is a 2D plane. I put my lift down, and I go up. Also, I'm in a high axis. And obviously distances will change. So I'm closer to the top ones, and I'm further from the bottom ones, I think. And if it's fun, let's quickly getting higher. Just for fun. Let's get above all of them. So I come back here. Also, I've still got the previous one here. And let's start a new one. So top this time for green is 21. Bottom is 23. Previously it was 20. Top red one is 18. And bottom red one is 20. Top blue is 13. And bottom is 16. So if you look at that, some slight differences. I think I've probably moved slightly as the top one's moved a bit. I mean, a slightly different. I'm like between 2 numbers probably. Some places, so that's why it's not exactly the same for the top ones. If I just put that in, we'll see, we get very similar. I think I'm pretty slightly off actually. Oh yeah, slightly off. Yeah, it's hard to tell. But it's very close, essentially the point is. It's not exactly accurate. But it gets very close to roughly where the coordinate is. So, yeah, a building, for example. So even if it's off by a few blocks, it doesn't really matter. It's a building. It's giant. Take from the middle, I think, or just bottom left. It'll essentially add up, and you go to those coordinates, you should be able to see it, I think. So it's a range of seeing the thing you're trying to get a coordinate of. It is. And obviously this is much higher, and it's roughly the same coordinate as down there. If so X has changed by about 0.4, 0.5-ish, and the Z is changed by 0.03-ish, for example here. So within decimals will change really. Essentially it's within the range of 1 of the actual coordinate. So for example, I could literally run all the way out into the wilderness over here, and I'll still be able to get a coordinate. It's not just limited to be within that square. So as you'll see for the Y coordinate, it was 10 high in all the towers. I don't really want to run too far. So if I put it out again in my calculator, obviously top green, now we're dealing with big numbers, which is probably a bit more accurate now at this distance. So that's hard. Obviously be within a block or so. Well, not a block, as a meter's obviously about 4.5-ish from what we can see from that little test setup I had prior. Boy, top one's 150, bottom one's also 150. Obviously that's pretty caused by the fact the towers are only 6 meters roughly. You look at the bottom beacon, we're standing in the top beacon, it's 6 meters different, so that's probably going to cause a little bit of uncertainty possibly, or it might not have as badly a big effect at the same time. Let's see, top bed is 140 and 140, so probably help to have these towers a bit wider. Then 133 for blue. And there you go. Obviously my x coordinate's gonna be bigger than my z because I ran more on the x-axis than the z-axis. So essentially the way my code works is it just calculates the height of a triangle, essentially. It knows all three sides, and with a bit of maths we can work out the height. So we start off by, also you have this point, and let's say I was standing where my lift is. So there's me, the lift. Yeah, just imagine that's me. Well, see, if we know this distance, we know that distance, and that distance is already predetermined. We find the height of that, which will be about here, somewhere in, obviously, be somewhere in this axis. So essentially, man, I don't know if I'm going to explain this well. So the height will essentially be as if I took it from this point on the 2D to here, without any interference of y. Because if I didn't subtract y from all this, let's say I have a really high spot, the distance is bigger here, I think. The distance will be bigger than that. Let's add one beacon here, which is the reason we have two. If I had one beacon here, we have a distance here, and let's say there's a point up there and a point up there, it'll think that point's further away, because it'd be thinking as if it's a 2D grid. So it'll think it's somewhere over here, when really these 2 points are just above each other. So it creates a bit of an optical illusion. So we had two to work out the height, which would be as if it's a 2D plane. Yeah, I think I'm explaining this correctly. But yeah, so we also find the height of this triangle. We do the same with the other two towers. And that essentially converts everything to work on the 2D plane. So y is essentially removed from all the numbers. Then once we've done that, we grab this one. Also we know the distance between these two towers. And then we know these two distances from calculating the height of these towers. Not the height of the towers, but the height of the triangle is formed prior. And then we just calculate the height again, which will be here. And obviously this isn't part of the x-axis, this will be for the z-axis as it will be going along this line. And then we do the same for this side, which will then obviously work out the x-axis. Now I don't know if my explain is exactly good, so I think it's better to show you what it actually looks like more on my okay, so here is where it started on Paint. I like to use Paint just because you can quickly put stuff together, even if it's a bit messy at points. But the equation I essentially use is this. Is all that. And obviously that's with numbers filled in. But it's all of that up there pretty much. What was the name of the Heron's formula? That's it. That's the one you use, which gives all this, essentially. Obviously here, this is a prior one. Or eventually, this is essentially when I started and I was trying to work out how you work out a point. That didn't work by the way. Or at least I couldn't find out how to work it. Same with that design. And this is probably where, mostly where the point is where I realised. There's obviously Y, and that's going to offset things. And so it's a little visual demonstration I tried to put together. Obviously imperfect, and it's made up of 2D shapes and just rotated in certain directions. So it's probably not a perfect cube either. The red lines there, this is where the point is meant to be. Yeah, as you can see here, got some test data here. So this size for A2 and 2.5. Put that through Heron's formula, we can get a height, which would be the height there, which in this case would be the Z height. So that's a nice visual version. We jump over to the coding side. So this is the code I wrote for it. Well, wrote for it, sorry. I can do English. Well, maybe not today. So this top bar here, just know that's just essentially a menu. Having all this here is where it gets to. I've tried to do it. So normally when I code, I use these weird variables. I've tried to explain it for anyone who's curious. So obviously there's spare mistakes in this as well. I forgot to go check all the spellings in this part. We'll see those. On coding, I don't really care about words unless they're in, like, being printed and that. Also here, you can recognize when it asks for the bottom or top red beacon, for example here. So the first stage, or first cluster, is this. So this goes through. First stage, obviously asking for it. It works out what the S value. If I go back here, we also need what S is, and that's obviously seen over here and throughout the rest of it here. That's not Python. And once we got that, you times it by 0.5. That's meant to be 1 over 2 in a fraction, but obviously I didn't know how to do fractions in Python, and this works the same anyway. It's a half still. Half is a half. Yeah. Just need to be careful how I use it, I think. It's the only difference. Then I finally put all together. So here it might get a bit hard. I think I should probably explain. C1 means corner 1. That's what this is meant to say, is corner. Those are towers, essentially. These first three are tower base. So obviously C1 here, C2 there for the second tower, and C3 for third tower. S is obviously the one I worked out here. And then obviously A, B, C. At the end of these are the individual variables up here. 2 input, 1 is preset. Obviously if you rebuilt this, you'll need a DIN number, as you'll need to see a distance between the beacons. Well, essentially it's just the Heron's formula repeated a couple times. So a total of 5. 3 for the towers, and then 2 for the actual coordinates. And I could do the same for Y. If I reflect, essentially I'll have half a triangle reflected the other side. It should, I'll go full triangle like that, essentially, with 3 sides, and be able to work out the height. And then I know the height of the object as well. But I also haven't done it yet. Nor how I use for it, as I want to prioritize putting together some form of way to save and then display it, which I'll do in the next part. But in practice, this actually has some issues with how I've coded it. As it finds the height of a triangle, so let's say here, from these 2 beacons, these all work in positive numbers. If I were to try to look for something on this side of the towers, this is still positive in its mind. It doesn't know the difference between which way it's facing, because it doesn't actually see any of that. It just sees a triangle and it works on it. So obviously to work it out, I'm probably gonna have to. Sometimes we'll have these 2. I'm gonna have to see if red's like bigger than green by a certain percent. For example, 20%. That's pretty too big, I think. But also if it's over here, red's probably gonna be bigger than green constantly. But obviously, if it's here, I need to make sure it doesn't see this as positive or sees this as negative. Type thing over here. So it has to have a bit of give, which might break it in a certain range of that. But that's the current idea I have. So for now, obviously it works fine in positive directions. For now, the only way that we use this is to put it at the bottom left of the world. Or, if you're someone like me and didn't realise the height of a triangle would still work beyond these beacons and towers, which was how I originally thought it worked. Later I found out it didn't work like that, it would actually still work. So also, I was able to get a coordinate over there still. I went to, well, my old survival world. It's not really a survival world anymore, I just use it for testing and that, and messing about, because I've finished everything and waiting for chapter 2. Speaking of chapter 2, Devlog 22 has been announced to probably come out next week. As on Twitter, they said they're going to do it. That's exciting. Hopefully they don't reveal a coordinate system, otherwise this has all been a waste of time. Yeah, we'll see. On my single player world, I literally built these at the corners of the world, which I guess would mean, possibly have a more accurate system, as these will be more separated. So Y will probably work a bit better, as it's not so compressed. But yeah, I built this from the bottom of the ocean to about 40-ish meters, I think, from the top of the world. If you go from the bottom of the ocean, it's at 1,040. I know I was able to get to 1,037 by building up. Essentially, I left myself jumping automatically, which you go on, for example, if you want to know how to do that, or even auto sprint, go and just hold it, go and chat and escape without touching it. Just automatically jump constantly. Press it again to cancel. Neat little trick if you don't know it. Yeah, and obviously, then when it got essentially an auto quicker to build, as it took a while to build up to the high. Yeah, so it was about 1,037. Obviously, that was below me. I didn't count like above me, but that's when my player started hitting the ceiling. So I'm assuming it probably goes up to roughly about 40 blocks over 1,000. So it might be a little less than that. Anyway, well, so yeah, obviously I can move this to the back left of the world, and oh yeah, I need to actually get a copy of this first. Export. Right, got a name. Let's call it Testwig. It was Testwig to start off with. Then my cargo file will work in, I think. Let's see. Hey, it works. About here will work. Let's try importing it. Probably put a space there. Boom, I am pretty sure I should float. Or did it attach itself to the ground? Attach itself to the ground. Okay. I guess it was connected to the ground over there. I guess that works. Just know it's in the bottom of the ocean, so I think it might be slightly high. Just get rid of these beacons. And as I'm here, let's go turn off the initial beacons. So I don't have those interfering. I know which ones are which. These are going to get very confusing. And let's go. No, let's go somewhere in the higher Z direction this time. Obviously, this is going to be very hard to tell that if it is correct, but it should be. In theory. No, let's actually just stop over here. I like this flyer. Oops, took off again. Jump out now, and let's see our distance. And let's set the calculator up. So let's see a new one. Top green. See down here is 1231. And obviously, because the height of these are not very high, these are actually gonna be the same numbers probably. Oh no, blue's off by 1. That's nice to see. Right, top red is 1213. Blast. This works. Lord, now I've just lost all my data. 12. Blast. Hope that works. Okay, there we go. You do something that's not a triangle, it does break it. There's no protection on any of those cells, so I can't even restart them. Okay, 1231. 1231. Top red is 1213. Then 1213. Top blue is and bottom is There you go. Oh, and again, I actually went too close to the Z coordinate. Whoops. But the X coordinate. Okay, so I just looked back at the recording. Actually, X I think might have been correct, but Z obviously bugged out for some reason. Oh, 10 yards far away from it. So I need to go straight. We're roughly somewhere over there. We actually landed. was, so actually X was probably quite correct. Just the distance looked really small. Also when you fly. I think. I'm gonna try is to go a bit more this way, I think. And let's try again. Obviously that was on that broke. Okay, so if we get the right ones, click back on that. Okay. So top green one is 1386, sorry. Then again, same. I'm worried maybe the height of the beacons is because there's not enough differential and it's roughly the same. It might be messing with it possibly in some way. Somehow it's messing with it possibly. Top red is 1372. Okay, so we got a slight difference of 1 this time. Oh yeah, they're the same numbers actually. Actually no, because the distance is there's a set distance between them, so no, I wouldn't make it a 2D line. Yeah, this is 73 after that. Top blue, 1370. No, they're both the same this time. $826. I wonder if I go above 1,000. Let's do a little experiment. If I go above 1,000, is that where it breaks? Now let's try from this location. Okay, so top green is 1361. I did it again. Okay, this time without messing up. So 1,361, 1,361 again. Top red, 1,344, 1,344. Top blue, 1,350, and 1,350. That's all the right numbers this time, right? Yes. It's all exactly the same. Okay, so we do have a coordinate this time. That's intriguing. That's interesting. We've actually got a coordinate. It is about 1,000. I think. Okay, so it failed over there. Failed some over there. Oh, let's go see where it failed. Da 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 da. Da 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 da. Da 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 da. And da da. 3, 12. There you go. Okay, those are the correct coordinates. Okay, so it worked here. So 1505, 1505. Top red, both the same as well. 4, 87, 14, 87, 14, 95, 14, 95. Okay, okay. That is really interesting. Were there 2 flukes? Well, I redid the code over there for the coordinates I got. It broke 3 times. I think I've tried it. I tried it on the other phone, the other thing I have Python, without going through the Python builder. Not builder, but they should code it. Okay, that's really interesting. Let's try to get something a bit of height though, you know? Ooh, that's great here. Yeah. Not my prettiest landing. Okay, so now we've got a lot of height. And very far away from the thing. Oh, no, God. I don't remember there being this many crates on top of these. Oh, it just appears to be where the crates are. Look at that loot. Yeah, now we're high up. Or you got any differential? Okay, yeah, we've got one difference here. I wonder if maybe that's why it messes up. Because the ones it messed up on is when it had one which is with a difference of 1 on the tower, which is interesting. The thing to note is this is also these two numbers and is 6, which is very tiny. So that might be where it messes up on, I think. Oh, actually that's a good point actually. It's 6. That'd be a very slim triangle, and it might have so many decimals. Calculate it at one point. It might delete decimals, which is why it's not getting proper numbers. It might be something to do like that, possibly. I'm not sure. So I don't think that would affect it. Not even badly. Aha. I think I figured it out. Right, red. Yeah, green and red are used to calculate x. I mean, there's a... Okay, if I was to add a meter onto this, would that fix it? That's a good question. Would that actually fix it? And okay, so that's what's causing the issue, is when it's one off of the other tower. I'm assuming it must have something to do with 6. So maybe if I increase it to like 20, I think I might fix it. So it does work at long distances. It's not like some sort of limit I'm hitting, because that is definitely greater than in the water. So let's do a really extreme test. Let's see if I can actually still get coordinates for the opposite corner. I think that's... Once I refuel, actually. Oh, there's the border. I'll clear this. I strap bubble raptors. Okay, here we go. Here's so green's here, blue's there. Where's the red? I think I turned it off by accident. That's why. Okay, the three are still here. Let's see. Obviously, I'm going to make sure these all the same, right? Yeah, all the same. So we shouldn't have that weird error. Not error, but weird number occur. Okay, so top green beacon is 9697. 9697. And remember, this thing ain't we didn't put the machine right in the corner. We just put it in the ocean at the bottom left. But it's pretty not far off of the bottom corner. Top red is 9685. I should take my finger off the enter key in case I did enter midway. And I'm reading the wrong one. 85, that one. Top blue is 9681. Then 9681. Yes, there's our coordinates for the map. I must have missed a lot of ocean on that side. On that, because I know one of these should go to 8,000, and the other should go about 7,000. I think. I'm thinking about the beacons I did in my survival world when I had the wrong idea how the triangles worked. But then again, that does sound accurate. Also, we might have actually bounced a lot off this issue. Well, okay, actually, before I end it, I just realised I've completely forgot I was gonna show you what I did in my survival world. Yeah. So this might actually fix the random if the two beacons are had different of one unit, it messes the number up. It does. This might fix it, to be honest. Yeah. Yeah, it's gas. Oh, the barriers are there. Top of the barrier. Yeah, though this will also be a lot harder to find in the logbook. On top of all my other beacons as well, actually. I think obviously this is the calculator is slightly different, as the distance between these beacons is obviously a lot bigger. I think it's a good way to say it. Okay, the first two I need are up there. The other two don't know where they are. Okay, so top green is 2078 and the bottom is 1830. So obviously these numbers are definitely different, so it might fix it. Top wed. Okay, I've got both of them in view there. So top wed is 4952. It's also my first time actually testing my survival one. Type of thing this is. So there's a chance it might fail. And again, it's gonna be hard to tell if it's fail. If it's in the like 3000s above, I'm gonna say yes, it'll probably be off. I don't think I'm that far out right now. Anyway, 48, 49. Top blue is 7259. I'm also definitely editing this tomorrow, probably. As you can probably see in the bottom right. Also, screen right now, you can see the time, it's 8. I started sometime during 6. So about an hour and a half to 2 hours I've been working on this. One blue beacon is 7192. Yeah, those look about correct. I would say. Yeah, those are actually about correct, I would say. Yeah. I'll see those numbers are a lot different. Yeah, I'll see it works. Nice. Back to the outro. Anyway, I think that'll do it for today's part. Actually, no, I've got one more thing to show you. It says I do this. So it's fun. And if you're curious about anything else and what I want to do in the future, there you go. So top is issues, and those are sort of plans. Some of these are more do future, and if I ever get around to it, might not do this. When I'm asked, might not do it. Depends. Depends if I can learn how to use that, or if I can get to work properly. I think. But yeah, essentially, I think the main one I'm going to work on for part 2 is going to be saving. So I'll probably say it was JSON file, and then obviously then export it to a spreadsheet. For example, we could have web crosses on the spreadsheet, or web points on the spreadsheet to represent where abandoned buildings are. Obviously it doesn't look like a map, but it would show if there's a cluster of them nearby, if there's a line. If you take a coordinate for each bit of road, like slowly walk along the road, take coordinates, you could also map the road out if you wanted to. And that would show like a rough scribble, not squirrel, but it would show lines and curves where the road went. So you would be able to eventually map it out. The idea. Anyway, that's gonna do it for today. It's been a while. And a bit puzzling at the same time. Yeah, I'll see you next time. Oh, I also need to add a new bug to this. What I need to do next time. And yeah, see ya.